Welcome back. In this video, we are given a double integral, so the integral from 0 to 3, and then the integral from the square root of the quantity x over 3 to 1 of my integrand is e to the y cubed dy dx. And what we're asked to do is to sketch the region of integration. Then we're going to reverse that order so we can evaluate it. So thinking about our region of integration, first we have dy, which means these are two y equals lines or curves, and then we have dx. So 0 to 3, those are my x values. Now, why might we want to reverse the order here? Do you guys know how to integrate this with respect to y? You don't. However, if we change this and we get dx written first, then this is a constant, and this is just going to become e to the y cubed times x, and it makes our life a little easier. So let's think about sketching our region in the xy plane. So I have x, I have y. Clearly, I see my x values go from 0 to 3. And then I have two y values. I've got y equals 1, so I'm going to draw a horizontal line here for y equals 1. And then I have this curve. You could plug it into your calculator and graph, but you're going to see it does something roughly like this. So it comes right over here to right above x equals 3. So I've got y equals 1, and then this green curve is y equals the square root of x over 3. And the region then is this region bounded inside all of these points, this roughly triangular, I guess we'd say a curved hypotenuse, so it's clearly not a triangle, but it's a roughly triangular region. And so we want to take this region in the xy plane, and we're going to map it up to this curve in space and find the volume between that region and the curve. Now, let's think about how we would reverse our order of integration. Up here we have dy dx, so we want to set this up so it's dx dy. I'm going to go ahead and give myself space. I've got two integrals. My integrand is e to the y cubed, so I have, that's not enough space. We have e to the y cubed, and we want to do dx dy. So y, my y values, that's going from 0 to 1. So those represent y values. What are my x functions bounding between? So on the left here, I have a vertical line, x equals 0. And on the right, so my left side is this, my right side, my further out, my greater bound, what is that function going to be in terms of x? We could square both sides. That gives us y squared equals x over 3, multiplied by 3 on both sides, and we have 3y squared equals x. So this is x equals 3y squared. So that's my setup, 0 to 1 on y. All right, there's my from 0 up to 1, those are my constant bounds, and then from x equals 0 over to this green function, which is now redefined x in terms of y, x equals 3y squared. So now that we've got it set up, let's integrate. So if we're integrating with respect to x first, that means all of this is a constant. And I'm going to end up with e to the y cubed times x. And we need to evaluate that x from x equals, I'll use my colors, x equals 3y squared and x equals 0. Once we plug those in for x, then we'll be able to integrate with respect to y after we simplify. So what this does for us, 3y squared goes in here. 0 is going to go in, and 0 times anything is going to zero that term out. So we have 0 to 1, 3y squared, e to the y cubed, dy. Now this is something we can handle integrating. At this point, we can integrate this. And I'll do a quick u substitution because I see that the derivative of y cubed, 3y squared, is inside my problem. So if we come over here and we say let u equal y cubed, then the derivative of u with respect to y is 3y squared, or rather we have du equals 3y squared dy. So there's my 3y squared dy. I'll let that be u, and I'll change my bounds. Don't forget to change your bounds. It makes your life easier if you do that. So u equals 1 cubed is 1. U equals 0 cubed is 0. So setting this up, the bounds actually didn't change. Even though we performed a calculation, they remained the same. And I have e. Y cubed is going to be my u value, and 3y squared dy, that is du. So now this is very easy to integrate because the integral of e to the u is e to the u. We just need to evaluate it from 1 to 0, which is e to the 1, minus e to the 0. E to the first is just e to the 0 is 1. We end up with e minus 1 representing the volume, and that's our exact value. So I did another example where we changed the bounds, and it was really probably fairly easy to integrate in either direction. But in this situation, we changed the bounds. It made our life way easier to figure out how to integrate it. So when you're dealing with a problem that's hard to figure out how to integrate, take a second, sketch that region, see what happens if you change the bounds. As always, email me, contact me, phone me, Google Voice, whatever. Leave a comment on this YouTube video. Ask questions.